Hello students, today we will evaluate limits numerically. What we did in section 10.1 was we analyzed the graph, looked from the left and right side of a particular point, and we were able to find our limit. Today we're going to do limits numerically, looking at a table of values. So we have the function f of x equals x cubed minus 1 all over x minus 1. X cannot equal 1. What you're going to notice is if you put x equals 1 here, you're going to have a 0 in the denominator. That will be a removable discontinuity, which is what we discussed last semester. So here is the limit of f of x as x approaches 1. We're going to find numbers to the left of 1. So to the left of 1, 0.99, 0.99, 0.9, 0.75. So from the left, these numbers are approaching 1 from the left. These numbers are approaching 1 from the right. So we start off with 1.25, 1.1, 1.01, 1.001. And from the left side and right side, we are approaching 1. X is approaching 1. Well, to calculate these values, get your graphing calculator. Put in y equals, put parentheses, x cube minus 1, close parentheses, divided by parentheses, x minus 1, close parentheses. So what you're going to do now is we are going to second calculate. We're going to calculate a value. So we will put in, let's see, 0.75. So 0.75, hit enter, and now you will get 2.312, which is 2.313. You will continue to do that. Put second calculate again, hit value, and put let's put 0.999. Enter. You will get 2.97. I'm sorry, 2.997. That's what we have here. And you're going to do it for the rest of these values. Now, you should be able to see a pattern here. From the left side of 1, we are approaching the number 3, because that's very close to 3. From the right side of 1, we are approaching the number 3. Therefore, the left side and the right side are both approaching 3. Therefore, our answer is the limit of f of x as x approaches 1 is equal to 3. Now, if you were to look at a graph, we can check the graph and we could see that from the left side of 1, which is right here, go up there, from the left side of 1 and from the right side of 1, we are approaching 3. So that was example 1. Moving on to example 2, the function is the absolute value of x divided by x. X cannot be 0 because we will have a discontinuity. So the limit of f of x as x approaches 0, this is f of x. Again, now we're looking at the left side of 0 and the right side of 0. The left side of 0 are negative numbers. The right side of 0 are positive numbers. Well, when we put these values in for x, on the left side, our y value is negative 1. On the right side, our y value is positive 1. So let's just enter this in our calculator. Go to math, and then you want number, you want ABS as absolute value. So there we put in x. Hit arrow to be out of the absolute value, divide by x. So let's graph this. Let's verify our graph. So let's see what we notice here. As x approaches 0, there is 0. From the left side, what is the y value? It's -1. As x approaches 0 from the right, what is our y value? It's +1. So if the y values are not approaching the same number, therefore we do not have a limit. The limit of f of x as x approaches 0 does not exist. Okay, that is it for today. Verify your answers by looking at the graph on your graphing calculator. Thank you and have a good day.